Hello friends, I hope you are doing great. Once again you are most welcome in my YouTube channel voidlooprobotech and Automation. Today we are going to learn how to change configured SPI data size while code is running. It means if you want to use 8-bit SPI slave and 16-bit SPI slave with common SPI, so you can use. Okay, so let us get started step by step. First of all, I'll create new project, go to file and new and STM32 project, and it will take a little bit time. Now go to board selector and type here board name, that is NUCLEO F411RE, and select this. Next, and type here project name, Change SPI Data Size. Okay, and now click on finish, and yes, okay, the project is creating. Okay, now go to pin outs and clear all pin outs, and yes, and go to clock configuration. Here I will select 16 megahertz. Whatever you required you can select here and press enter. Okay, go to pin outs and configuration and connectivity and click on SPI1. Select here full duplex master. You can see here pins are assigned PA5, PA6 and PA7. Here this is 8-bit data size and MSB first, and baud rate is 8 Mbps. You can change by changing the prescaler. I will select 1 Mbps, then it will be 16, and everything is okay. Now click on save, and yes, it will generate the code, and again yes, now it is generating the code. Now we will declare variable for transmit buffer and receive buffer. So transmit buffer will be 4 byte and it will be 1 2 3 4, and receive buffer 8 byte receive buffer. Okay, now copy and paste, and now declare the variable for 16-bit SPI configuration, then receive and transmit data buffer for 16-bit. It will be 2 byte, and I will send 24AB and 0x52CB. okay, now go to in while loop and call here HAL SPI trans receive function. Here it will be transmitted and receive TX buffer. Okay, and receive message will be received into RX buffer, and pass here address of SPI handle and transmit buffer and receive buffer, and size will be 4 byte, and timeout it will be HAL max delay. Okay, and again I will copy and paste, edit here 16-bit receive buffer. It will be RX data 16 and TX data 16. Okay, it will be 2 byte. Now I am trying to send and receive 16-bit data. So click on build. I think there is a error. What is error? Error is, okay, it will be HSPI1. Okay, now again click on build. Okay, there is a warning, we have to typecast into 8-bit here. I will tell you why I am doing this. Go to its declaration, and here you can see TX data and RX data buffer is 8-bit. okay, that's why we need to typecast here. Okay, you can see in the board Mosi and Miso is sorted. Okay, whatever I will send, it will be received on Miso pin. Okay, so now click on debug. Select here debugger and select ST-Link and scan and apply, then OK. Now debugging will be started. Switch. Okay. Now remove these this variable. Okay, remove all and add here RX data for 8-bit and RX data for 16-bit variable. Okay, expand this. Okay, now we will add breakpoint here. When debugging will be resume, then it will be hitted. Okay, now do one step over. You can see 1 2 3 4 was received into RX data for 8-bit. Okay, one step next. See, only 2 bytes are received. Okay, all 4 bytes was not received. So to do this thing, we have to define a function. So okay, you can see here, this is change SPI data size function. We have to pass SPI handle and SPI size. So first of all, we have to disable the SPI and de-init the SPI. After that, assign the SPI data, then initialize the SPI and enable, and again enable the SPI. Okay, so I will declare this function, paste here. Okay, now I will call the function after 8-bit data sending here. Okay, it will change the SPI configuration from 8-bit to whatever you want. So here I will change 8-bit config into 16-bit. Okay, this is SPI 1, and for 16-bit there is a macro. Click over here and go to open declaration. You can see this is SPI data size underscore 16-bit macro, and paste here. Okay, now again copy and paste here. Okay, and change it into 8-bit again. Okay, and now terminate and relaunch the debugging. Okay, expand this and start the debugging. One step next. As usual, you can see it is 1 2 3 4, and now one step next. Again next. Wow, you can see it received all 4 byte. It means now SPI is converted into 16-bit. Okay, again one step next. Okay, it is not highlighting because there is data is not changing. Okay, so friends, I hope you enjoyed this video. If you really like this video, please do like, subscribe and share. Thanks for watching.